Hello again, this is SER 321, Principles of Distributed Software Systems, and today I want to talk about Unit 6, which is object-based client-server communications. Object-based meaning that we're going to view the server as an object that has the ability to have its state modified by calling methods and so forth. So object-based client-server communication. There is a section in Java Network Programming and Distributed Computing, Chapter 11, which covers RMI, so we're going to go through that. And there's also an exercise, a lab exercise on RMI. There, oh, I don't know what happened to that. I'll have to figure that one out. There's a lab exercise on RMI where you have to demonstrate actually what I'm going to do in this video, and that is, I hope that works better than the assignment page, and that is to run the RMI server on your Raspberry Pi and to run a client on your Debian Linux box. So we're going to talk about RMI because it's a very interesting approach. It's a similar approach to other similar approaches that have been around for quite a while. But RMI is a very good place to start in terms of doing distributed computing. Object level, so from one perspective, although there's some overhead that's necessary to get things set up properly, working with RMI, distributed components in RMI, a lot of the heavyweight lifting is already taken care of for you. So that makes it very straightforward to do it. In terms of the Raspberry Pi, if you haven't gotten yours set up yet, some of the points on this assignment are assigned for completing, for having your Raspberry Pi set up and demonstrating that in fact it will run the server and your client can communicate to it. There is a page for configuring the Raspberry Pi. I've had several folks ask whether it matters whether or not you do a direct Ethernet connection to a laptop or another system. I really don't care how you get it on the network. The important thing is to get the Raspberry Pi on the network. The reason that this page talks and favors that approach is because it's very straightforward to do on an OS X device. I've done it about 2 years ago on a Windows device, but I don't know for sure if the software I use to do it is still available. And the advantage of that direct connection is that you don't have to plug the Raspberry Pi into a keyboard and a display. So if you've got an expert keyboard and display, it may be the easiest thing to just do that, plug that in, and then configure either wireless or a direct connection, however you choose to do it. Whichever is more straightforward to you. You don't really have to, for those of you that are in the face-to-face class, you're never going to be really required to bring the Raspberry Pi to class. You're more than welcome to if you want to. Certainly if you have questions on getting it configured or getting stuff to run on it. Bring it. But on the other hand, if you configure it wirelessly so that it only works with a specific router, that's not a problem as far as I'm concerned. You'll still be able to do screenshots and to be able to submit homework solutions that use it that way. Okay, so enough of Raspberry Pi. Let's take a look at RMI. So RMI has been around since the very beginning of Java, remote method invocation. We're not going to talk about .NET remoting, although it's in here. But from my perspective, we're going to primarily focus on Java RMI. So what are distributed objects so that you can understand them a little bit better? Distributed objects provide the ability for distributed components to communicate with each other at the object level. Right? So what that means is instead of having to open up a byte stream, an input stream and an output stream, and send data back and forth over that stream, what you end up doing is saying, okay, my remote component is an object, and I'm going to send a message to that object by calling a method and passing that method arguments, right? And then the method can return for you some results. So it looks just like it's an internal object, internal to your program, although it's called a remote object reference. Instead of actually having an internal object reference, a reference to an object on the heap in Java, what you actually have is a remote object reference. And we'll be sending a method invocation to that remote object reference. Okay, so arguments, call and synchronization, return values, they all get handled by the platform and not by the application developer. And as you'll see more and more, the next thing RPC, you're going to handle more of the infrastructure in RPC. And then when we do stream-based sockets, in fact, you'll see you'll be handling the application developer handles, well, there's still a bunch of stuff below it, but the application developer handles a lot more of the infrastructure in order to get it to work. Okay, so let's, I think there's a, the next thing is a vision of distributed objects. So the idea behind motivating distributed object computing is that you can end up with these federations of objects, distributed objects, so that to perform a task you may actually broker to have the ability to work with several different objects that may be on several different machines, literally distributed anywhere, that provide different portions of a problem solution that you need, of a solution to a problem that you need to have solved. And it provides the ability to communicate at the same level as if you were doing object-based computing within a single program. So this idea of service providers and viewing the internet as an object bus where messages communicate back and forth to different objects. It's kind of an interesting approach to doing distribution. In many respects, somewhat similar to the semantic web, but instead of exclusively to the web, it is for the entire internet. Okay, so I think I missed one here. Yeah, distributed object landscape. We're going to look at remote procedure call. It's been around for quite a while. We're going to look at it in the context of JSON. .NET remoting, as I mentioned, is the .NET Framework's approach, very similar to RMI. One difference is that .NET remoting defines different kinds of remote objects, and actually, frankly, does a little bit better job of dealing with the life cycle of a remote object. It actually allows you to lease how long an object is supposed to be available. And when its lease expires, if someone hasn't renewed the lease, then in fact it'll be destroyed. With RMI, it's a little bit different approach. It's more of a reference counting approach that's used. I mentioned actually Common Object Request Broker architecture by the Object Management Group, OMG. So the interesting thing about OMG, it shares, the Object Request Broker, it shares a little bit with Remote Procedure Call in that it's intended to be multi-language. So you can have a C client communicating with a Java server, vice versa, or whatever language mixture that you want. There's actually many languages that have implemented to the Common Object, to the Corba. And there's also been many different languages that have implemented to RPC as well. Both of those technologies are multi-language. .NET remoting, on the other hand, .NET remoting is only multi-language from the perspective of the .NET protocols, or anyone that wanted to implement their protocol within a different language. And the same is true for RMI. So here's I think a very good picture of RMI. We have on the right-hand side an object server, and the left-hand side a client. So presumably these are executing Java programs. And the red line connecting them is intended to be kind of the virtual connection that allows the client to invoke methods on the server. So in this particular case, well, in the paradigm, the strictly one-way paradigm, we can do it both ways where they can both be servers. But it is a client-server sort of a model in the same way that we have an object that provides services, and a client of that object actually calls those methods in order to get those services performed. And that's exactly what happens in our client object here. At the physical realization of RMI is in terms of what's called a stub on the client side and a skeleton on the server side. And on the client side, the stub looks just like the interface to the object. In other words, it's a set of methods that are available. It's just that the implementation of those methods occurs over here on the right-hand side. And the skeleton is the other side of that, if you will. It's the implementation part. So what happens on the skeleton side is that a request comes in over the internet. It decodes that request and sends it to the appropriate method implementation inside the object server. So the stub and the skeleton communicate with each other using TCP/IP sockets. So in fact, the skeleton really is a threaded server that has the ability to recognize multiple clients and to manage the requests that those clients may make in such a way that synchronization is assured and so forth, to be able to package up, or excuse me, on the skeleton side, on the server side, to decode arguments that come across, send those to the server, and then take the resulting output of the method call, right? The result of the method call, and packaging it up. It's called marshalling and unmarshalling. Packaging it up and sending it back to the stub side. Okay, so proxy and stub. The proxy and stub have always been. There is a special JDK tool that allows you to build the proxy and the stub, or the skeleton and the stub. Although in recent releases of the JDK, they can be built automatically, dynamically for you, which makes things a little bit easier for the implementer. So here is a full-blown picture of what is commonly available when a distributed application uses RMI. On the server, on the client side, is a client that is using the services that are provided by a remote object server. These black dots are intended to represent the fact that it's not necessary that there's only one server object. There may be many objects, right? It may be a collection of objects. So for example, in the media library, could very well be the case in the application that we're working on. If we were going to use RMI, we may want to make each of the media description objects a remote object. Or we have the choice, we could actually make those media description objects serializable objects, so that they would be copied and passed back to the client. As a remote object, so these black things the black dots are denoting remote objects, meaning that the remote object server may have several different remote objects that it uses to satisfy requests. And the request from any given client may actually go to any one of these remote objects. Obviously it only goes to one object at a time. I call one method on one object, but there may be many different methods, and one remote object may return to me a reference to a different remote object that I then call with a different request. So in addition to the server, which was in the previous diagram as well, I'm not showing the stub and skeleton in this picture, and the client, in addition to those two components of this distributed application, there is a registry, which is like a name server, meaning that initially the client knows how to get to the registry, goes to that registry to get the reference to a registered remote object server. So at least one of these black dots is registered in the registry, and the client goes to the registry to get a reference to one of those black dots, and then it can communicate directly with the black dot. So that takes care of the notion of the registry. That's the arrow pointing from the remote object server to the registry says that once a remote object gets created, one of those remote objects has to be registered with the registry, and it registers itself, or there's a program that registers it on its behalf, whoever creates that remote object. We also have on both sides web servers. And web servers are used in case, and it can happen in certain situations, but since this is an object-based technology and serialization is really just taking the data of an object and streamifying it, right, passing it through one of these arcs in one direction or the other, it could very well be that if the client receives a serialized object from the server, it may not have already loaded the class for that serializable object. And in fact, it may not even be in the client's class path. Right? So if, for example, a remote object server method returns, maybe it returns a person, an object of type person. Well, since it's possible that a student may extend person, the remote object server may return a student person, right? So if class student extends person, well, the client may not have known what a student was before it made the call. It may already have a person class, or presumably would have a person class, but it may not have the extended class student. And in order to get that extended class student, the system is built in such a way that the client could go to this web server automatically, the programmer doesn't have to do anything, and download the .class file for a student, which extends person, and it gets loaded into the client dynamically so that the client knows how to deal with this student that got returned from a remote object. And of course the same thing can happen in the other direction, right? The client may call a method and pass a more specific type. All right, may pass a student when the server thought he was going to get a client or person, and if the server doesn't know what a client is, then in fact it'll go to a web server over here and try and download the student.class file. So that's kind of dangerous. You know, I mean, if you can create a client that will send a serialized object of a class that a server didn't know about beforehand, and the server will automatically download that .class file, one has to be pretty concerned about permissions and security. And Java has, it's well thought out. As long as the application developer uses all of the facilities that are available for permissions, which can get kind of complex, but nevertheless you can develop very secure applications on top of RMI with all of this very dynamic capability. Okay, so I probably said more about that than I had intended, but that's okay. Steps to creating an RMI, a remote object and client. Well, the important points of it are the following. There is a Java interface, and that interface extends java.rmi remote. And both the client and the server agree on that interface. So each of these black dots, each of these remote objects, has an interface that it implements. More than one may implement the same interface, but in fact there has to be an interface for every remote object. And then there is a class on the server side that implements that interface, and it extends either activatable or unicast remote. You can get away without extending one of those if you do some other stuff, but generally the easiest thing is to extend one of these two classes. They're different. There are two different options that have to do with the life cycle, how long the server object stays around. Generate a main program to construct an object of the remote class. So this is a main program that's going to register the remote object with the registry, create a remote object and register it with the registry, and then create a client that's going to use it. Compile both the object server and the client with a Java-C compiler. Optionally, if you want to, you can create the stub class and the skeleton classes, or they can be created dynamically depending upon what you want to do. Then you start up the name service, start up the server, and start up the client. So I don't want to say anything more about activatable and unicast remote objects. They, as I mentioned, they provide the ability, essentially activatable means that if a server object has been collected, garbage collected, gone away, then if it extends activatable, if someone else comes and requests it, then it will be restarted. A new server object will be created. And that's not the case with unicast remote object. So this actually is kind of important to understand how things work between in the communication between the client and the server. With JavaRMI, a method can be a remote object method if the three conditions hold, or three types of parameters and return types can exist for it. So a parameter or a return type can be anything that implements serializable. Right? Anything that's serializable can be either an argument to a remote method, or it can be returned from a remote method. Same thing is true for primitives, so you can send booleans and ints and doubles back and forth all you want. And you can also send back and forth remote object references. Right? So I have in parentheses call by value for serializable, which really is make a copy and send it. And I have call by reference for remote Java objects. And in SER 221, I know that you, in the context of C++, looked at the difference between those two. It's actually fairly significant. You literally, when you use call by value or copy, a very similar mechanism, you make a copy of the object and you send it. So when a method gets called on the copy of that object, it doesn't affect the original object. That's not the case for remote objects with call by reference. You don't pass a copy of the object, you actually pass a reference to the object. So if you go around passing references to a single object, then everybody you pass the reference to can make a call on that object and cause that object to change. Okay, so marshalling is the term that refers to streamifying parameters, and unmarshalling refers to deserializing those parameters when they reach their destination. And that's the duty of the stub and the skeleton. The stub on the client side and the skeleton on the server side. So the restrictions for methods, for arguments to a method or parameters to a method, and for return types is one difference between local objects and remote objects. There's those three restrictions actually do restrict parameters and return types. And of course, there is just an implementation, a latency that exists between the time the client makes a method call and the time the method call returns. In method calls using RMI, there's two different terms to refer to the type of methods. One of them is synchronous and the other one is asynchronous. Well, synchronous means these are synchronous method calls, meaning that when the client makes a call to a method, even if it takes 2 minutes for that method to complete execution, you know, maybe I make the method call here in Mesa, and the remote object is running in New York. It may take a minute for it to respond to me. Well, my program is not going to proceed beyond that call until after New York has responded and given me back my result. That's called a synchronous method call. An asynchronous method call, not supported by JavaRMI, but an interesting thing to look at for messaging systems, doesn't work like that. So in Mesa, if I'm making an asynchronous call, I will make the call. It sends a message to whoever it is that I'm calling, but I go on immediately and continue. And then when the method completes, I'll get a message back that says, oh, it's done, right? So I have a callback, essentially a method that gets invoked when New York finally finishes generating my result that says, okay, your result's ready. If you want it, come and get it, sort of a thing. Okay, so these are all synchronous method calls. And there are exceptions that are defined that also can occur. So here's the example we want to look at, and we're going to end with this. This is the example that I want you to run on your Raspberry Pi. So I'm going to demonstrate it on the Raspberry Pi. It is about as simple of an RMI example as I could conceive. It does nothing meaningful, but I have the RMI registry. I don't have the web servers running. You actually have to start those up separately yourself and get them hooked into the RMI system. I have an employee object. An employee object just has a name and then an employee number. So there are two employees, Bob and Sue. Bob has an employee number of 100. Sue has an employee number of 200. And there is one method that's implemented, only one method, and it's get the employee. So I have an employee object that is serializable when the client calls get employee and provides the employee number that it wants. It will get back a serialized copy of either Bob or Sue. All right, so the remote object server, the RMI server, has an array of employee objects, and when a get employee request comes in, it looks to see which of the objects has the same ID, and then it returns, by serializing it, returns that object. All right, so you'll see in terms of implementation, when we read the code, from the programmer's perspective, there's very little that has to be done. It literally looks like server.getEMP, and it returns an EMP object, just like any other method call that would exist in your Java program. But in its implementation, that call is going through a stub, and then the stub is making a TCP/IP connection to the server. The server is accepting that connection, and then it reads on its input stream to get the employee object. It deserializes it. It's an object input stream. Deserializes it to make it into an employee, and then the skeleton over here calls the implementation of, in this case, get EMP to get the result, to get the employee result. I'm sorry, I've talked about it in reverse. The EMP actually flows in the other direction, but what I said is accurate, just going the other way. Okay, so very simple application, and I've already downloaded it, so I'm going to run it on my Raspberry Pi and also run it on Debian Linux. And I'm already on Debian, so let's do just to show you. So my Raspberry Pi, I actually have Pi configured to run wireless. Most of the Pi kits that you buy have a wireless USB, so I've configured it on my wireless router, so I don't have to have an internet connection to it. The only thing I have is power connecting it. So it's got an IP that's given by my router, and I can connect to it. Before I connect to it, so there's EMP employee.jar that I've downloaded, SCP. I like to preserve the modification time, employee.jar to Lindquist at, and now the IP address 10.0.1.18 is the address that Pi got from the router, and I want to put it into SER321/examples. Now let's shell to it. That's not going to work. That one might. So I've logged on to the Raspberry Pi, and now I've extracted the employee project. And we're just going to go ahead and get the server running here. So on this side, in order to get the server running, ant server, and you have to define on both sides, since it uses the RMI registry, you have to define on both sides both the IP and the registry's socket. And I've got that as properties, and I don't remember what's in the build.xml by default, but certainly host ID is not 10.0.1.18, and define reg port equals 2020. All right, so remember we talked about ant as a build file. There are properties defined in the build.xml, host ID and reg port, and I've overridden their definitions as they exist in the build file to actually give the appropriate IP for my Raspberry Pi. So the code we'll see when we read it. When it gets bound, when an object, an employee server object gets created and bound in the registry, it comes out and prints out this message. So here is the protocol. So now the client is going to actually go to the RMI server, excuse me, the RMI registry, and it'll use that exact same URL in order to find the employee server object. So now let's go back to the Debian VirtualBox. And I'm going to extract employee, the project, change to the folder for it, and ant client, and then define host ID equals 10.0.1.18, and define reg port equals 2020. So this tells me that the message says client has obtained the remote object reference to the employee server at 10.0.1.18:2020 employee server. And this is a very simple GUI interface. It's actually a dialog box. Enter employee number 100, 200, or end. So end will end the program. So these are the only two employees that it knows about. So if I ask for employee number 100 and then click the OK button. Notice up here on the Raspberry Pi, completing the request for employee number 100. Down here, you requested information about employee number 100. From the server, employee 100 has the name Bob. And I pop up another little dialog. You requested information about employee 100 whose name is Bob. Right? And very uninteresting application. But those are the best kind, right? So there's employee 200. Now you can enter end. If you enter anything other than 100 and 200, you get you request information employee 300, Java language null pointer exception, meaning that it returned a null pointer, and it just died. So that's the way it works. I don't have to enter end that way. Okay, so there's an example of using an RMI application, client and server, and I would like to take a look at, if I can get the right application up, I would like to look at the code, and then we'll end with that. So let me go to the server first. So in the source directory there are two subdirectories, a server subdirectory and a client subdirectory. So in the server, here's where we define the employee.java. Very simple. Public class employee EMP implements java.io.serializable. So it's a serializable object. It has two private fields, an integer ID, 100 or 200, and a string name, Bob or Sue. Its constructor just sets the values based upon arguments that come in. And then it has the ability to do a get name. This isn't the same thing that's implemented by the server, right? This is just a serializable. So this class actually has to exist in both the client and the server, right? It has to exist in both the client and the server. It may not be there when the server starts up, when the client starts up, but it has to be in the class path of the client in order for it to load it. So those are a couple of methods to be able to get. You can't change either the name or the ID. And let's look at the remote interface. That was the first thing actually that you need to do. So this is the agreement between the client and the server. So interface EMP server extends remote, and every one of the methods is only one method, get employee, based upon the employee's number, and it will return a serializable EMP object. Every remote method has to declare that it throws a remote exception. Consequently, the client has to handle that remote exception. So nothing to the EMP interface. Our EMP server impl is going to implement that interface, and it's also going to, in this case, extend. So employee server impl extends unicast remote object. Remember I said activatable. There's actually, you have to create the thing called an RMI daemon if you're going to use activatable, and we're not going to mess with that. And it implements the EMP server interface. All right, so this is the media library, if you will. If we were going to do it in RMI, we're not, but that's what it would be. Protected EMP is an array. Right, an array of EMPs, and just give it a literal new EMP Bob of 100, new EMP Sue of 200. So there's my repository of employee objects. I've got two objects in the array, one employee object for Bob and one employee object for Sue. And then my constructor does nothing. And here's the implementation of the EMP get EMP method, and all it does is go down through the list, or go down through the array EMP list, to check and see if the ID is the one that was requested, and if it is, then instead of returning null, it's going to return EMP list at I, right? And it tells which one got requested. So there is the implementation of the only remote method. Now the main, so this is the main on the server side, remember. The main on the server side has to create the remote object in this case, and it has to register it with the RMI registry. So let's look at how that gets done. Here's the creation of the remote object. In yellow, EMP server OBJ is a new EMP server impl. All right, so notice I use the name of the interface on the left. All right, so OBJ is an object that implements the EMP server interface, and in fact, now I'm going to bind it. So naming, this is in, probably should have had this fully qualified package. Java.rmi.naming is the name of the class. It has a static method called rebind that will actually take as an argument an RMI string protocol and an object. And that string protocol, RMI:// host ID 10.0.1.18, registry port 2020. So here's my : 2020 /EMP server. So there's the registration name and the object that's being registered. In naming is the class that represents the RMI registry. And then I just send out a message that says I got it registered. Right, so that's all I need to do, and it looks like I returned from it, but the registry keeps a reference to OBJ. The RMI registry keeps a reference to OBJ, and in fact, as long as some client requests that reference, requests a copy of the reference, requests a reference to the remote object, then OBJ will be kept active for a certain period of time that you can control. Okay, so now let's take a look at the client. OS name has nothing to do with it. It's just a method to pin out the property, one of the system properties. Not sure why it got left in here. So here's the GUI part of it. This is our first exposure to MVC. And we'll talk more about it, but this class, I hope, does nothing more than take care of the construction of the GUI. All right, and in this case, nope, actually that's not the case. So it defines an employee, EMP object employee, and then it does a lookup of a server, all right, the employee server, naming.lookup, and it gives host ID registry port, all right, RMI colon. And that is going to go to the registry that is running on, so remember now, the code that we just got through reading is code that's running right now on the Raspberry Pi. This code is code that's running on my laptop. All right, when I do naming.lookup, it actually goes to the Raspberry Pi, the RMI registry running on the Raspberry Pi, and gets a remote object reference. So now server becomes a remote object reference. It is an RMI server that implements the EMP server interface. So now I can call it so I create a input dialog, and when the dialog completes, somewhere down here, server.emp. All right, so after it completes, I get the string back from it. In string is the result of that input dialog, right? So the input dialog pops up the window, lets me enter it and select OK, and when I select OK, in string comes back to me as the string, it's either string 100 or 200. All right, so that's how I parse. That's why I have to do integer.parse to turn it into an int, and I call EMP method on the server, and I'm going to get back an employee, which is, as shown up here, an EMP object. All right, so serializable. What happens in execution of this method is that this get EMP is a method that's implemented by the stub, the RMI stub running in the client. It transfers that call together with a serialized version. Well, actually, there's nothing to serialize. It's an integer. The integer, in this case 100 or 200, to the server. The server's skeleton decodes that, unmarshals it, the int, and packages that up in a call to the method get EMP. The skeleton gets back from the server an EMP object, which it serializes and sends back to the client. So the client stub gets that EMP back, and then it passes it back as the value of employee. And then the rest of it is to just pop up the message that says, I got the employee, and here's what the employee's name is. Notice that employee.getName is called on the client, and it actually executes on the client. So now I have a replicated copy. I have a new copy, in this case of whichever one I asked for, Bob or Sue, of the employee object that is on the server as well, right? So serialization makes a copy. So getName method actually runs on the client and not on the server. Okay, more than enough. Let's leave it at that, and let me go back to here. So that's all I'm going to say about RMI. The next assignment is for you to get RMI to run on your Raspberry Pi, and just like I just did in this video. Notice that, in fact, here's some points that you might go through in looking at it. I will ask you questions about JavaRMI. We're not going to implement or create a new JavaRMI. One of the things I thought about was to, well, let's go ahead and make a media library RMI server, but doing that, there's enough code to write this semester without doing that. And I think actually you see that doing RMI applications is actually a very straightforward sort of a thing. So let's leave it at that, and let me go back to the main page. I will take care of this bad link for the RMI exercise and get it fixed.